So this is G485 homework booklet question 22, and it's about beta decay. So there are two types of beta decay, beta plus and beta minus. An isotope of carbon 15 decays by beta emission. You'll notice it's not saying which type, into an isotope of nitrogen. An isotope of phosphorus decays by beta decay. Again, it's not saying which one, into an isotope of silicon 30. Complete the following decay equations for the carbon and phosphorus isotopes. So the carbon, pretty straightforwardly, you're told the information for nitrogen, so it makes no sense other than to copy that in. And then to make the proton numbers balance, I've got 7 there. I started with 6, so I've got to have 7. That must be -1, so that's 0 minus 1. An electron, and possibly I could have even put that E minus there. Probably wouldn't have been a bad idea. And let's not forget that we've also got a neutrino in these beta decays, and because this is an electron, which is a particle, then the neutrino must be an antiparticle, so it's actually an antineutrino. For the phosphorus decay, again, I can drop straight in, put in the silicon 30, 14 silicon. Again, then I can look at the proton numbers. I've got 15 on the left, I've got 14 on the right, so I need another 1. So I've got 0,1 E, and that, if I wanted to, I could even put in that was an E plus, a beta plus. Because that's an antiparticle, that must be a particle. So the idea in both cases is that I end up with a lepton and an antilepton. That then kind of balances the fact that there are no leptons on the left hand side of the equation. You're asked then to say what's going on in terms of the quark model. For beta plus, remember what I'm doing in terms of beta plus is I'm going from a neutron to a proton, and so take that back, I'm going from a proton to a neutron, so that's the up down to up down, which you can even summarize right down to up to down. For beta minus, I'm going from a neutron to a proton, so up down to up down, or if you like, simply that down to that up. This is the only type of question I've ever seen on the weak nuclear force, which is to simply name the force responsible for beta decay, and you need to be able to learn the phrase that the weak nuclear force is responsible for beta decay. It's all you've got to ever do with the weak force. I'm not quite sure what they've put it on the spec for. Maybe so you've got some idea that it exists. So that's all we've got to do for G485 question 22.